Git hooks. Pre-commit, pre-push. What are Git hooks? Git hooks equal scripts that run automatically when certain Git events happen. They can run when you commit code, push code, merge branches, rebase commits. Why? Automate checks, prevent bad code, enforce rules, save review time. Where are Git hooks stored? Hooks are stored in .git hooks. Examples: pre-commit, pre-push, commit msg, post-merge. Why? Git runs these scripts automatically. No need to type commands. 1. Pre-commit hook. What is pre-commit? Pre-commit runs before a commit is created. It checks your code before Git saves it. Why? Stops bad commits early. Ensures code quality. What can pre-commit do? It can run linting, ESLint, check style, run formatting, prettier, black, run unit tests, check for secrets, API keys, block large files. Why? Catches mistakes before commit, keeps repo clean. Example use case, concept. If code has cross-mark syntax error, cross-mark failed tests, cross-mark bad formatting, then commit is blocked cross-mark. Why? Forces developer to fix issues. 2. Pre-push hook. What is pre-push? Pre-push runs before code is pushed to remote repository. Why? Final safety check. Protects shared branches. What can pre-push do? It can run full test suite, check branch name rules, prevent push to main, check commit messages, scan for secrets. Why? Prevents broken code from reaching server, protects team branches. 3. Difference between pre-commit and pre-push. Pre-commit runs before commit, fast checks, local quality gate. Pre-push runs before push, slower checks allowed, team safety gate. Why? Pre-commit equals personal guard, pre-push equals team guard. 4. Why Git hooks are important. Git hooks help maintain coding standards, reduce bugs, automate checks, improve teamwork, avoid human mistakes. Why? Machines are stricter than humans. Prevents lazy mistakes. 5. Types of Git hooks. Client-side hooks. Pre-commit, pre-push, commit msg. Server-side hooks. Pre-receive, update, post-receive. Why? Client equals runs on developer machine. Server equals runs on Git server. 6. Common use cases. Use Git hooks for code formatting, linting, test enforcement, commit message rules, security scanning, prevent force push. Why? Automates discipline, saves review effort. 7. Popular tools for Git hooks. Tools that manage hooks. Husky, pre-commit, Python tool, left hook. Why? Easier setup, works across teams, version controlled. 8. Limitations of Git hooks. Problems. Hooks are local by default, not shared automatically, can be bypassed, may slow workflow. Why? Need discipline, need team agreement. 9. Best practices. Best practices. Keep hooks fast. Don't run heavy tests in pre-commit. Use pre-push for heavy checks. Share hooks using tools. Document hook behavior. Why? Developers won't disable slow hooks. Keeps workflow smooth. 10. Common beginner mistakes. Writing slow hooks. Not sharing hooks. Blocking commits without message. Forgetting hooks exist. Relying only on hooks for security. Why? Causes frustration. Creates confusion. 11. When not to use hooks. Avoid hooks when running very long tasks, blocking emergency fixes, working in quick prototypes, no team agreement. Why? Hooks should help, not hurt. Real life example. Git hooks equals security guard at office gate. Pre-commit equals ID check at entry. Pre-push equals bag check before exit. Why? Stops problems early. Protects everyone. In simple words, Git hooks equals automatic rules. Pre-commit equals before saving. Pre-push equals before sharing. Hooks equals robot reviewer. They stop bad code before humans see it. Git hooks equals automation for discipline.